सबैले सुनेको छौ? स्नेहा सुनेको छ?
हजुर म्याम।
सुनेको छ है। False position method. Okay, the oldest method for finding the real root of non-linear equation f of x equals to 0. Let me discuss what is non-linear equation. स्नेहाले भन्नु त non-linear equation. Equation having degree 1 like ax plus b, 2x plus 5, 2x plus 5y equals to 0. Everyone listen carefully. This is the equation having degree 1. We always call linear equation. Okay, non-linear equation means equation having more than 1 degree. X square plus 5x plus 6 equals to 0. X cube, y equals to x cube, like this non-linear equation having the degree more than 1. Everyone, we discuss here how to solve our non-linear equation. The oldest false position method is one of the oldest method. The method is also known as regula falsi or method of chord, right? We call this is the method of chord. We derive our formula from the concept of method of chord. In this method, we choose 2 point A and B. Okay, we have the continuous function defined on some closed interval AB, where FA and FB are opposite sign. Okay, we choose 2 point A and B such that FA and FE have opposite sign, that is the root lies between A and B. If this condition holds, we claim our root lies between A and B. Okay, function should be continuous and defined on some closed interval AB, where FA and FE are opposite sign, then root lies between A and B. We can follow the false position method if we have this condition. Now, how to find? Let me discuss how to find the root formula or formula for false position method to solve some non-linear equation. Okay, see everyone, see here we have the curve y equals to f of x. It defined on some closed interval A and B. Okay, where FA and FE are opposite sign. We have the chord. See everyone, chord AB, chord. We see the chord, this chord. Dekhiracho. Okay, this position we called F. A, F of A, coordinate of this. This B, F of B. Okay, this coordinate B, F of B. What is the slope of the chord? We have the formula y minus y1 equals to y2 minus y1 over x2 minus x1 times x minus x1. Okay, this is the equation of the chord joining the point A of A and B of B. Everyone know this is the equation of chord. The chord joining the point coordinate A of A and B of B. We have this chord. Okay. Initially, x, how can we find this x naught? Let we discuss x naught is the first approximate roots. Okay. How can we find this x naught? As y equals, as equals to x naught, what is y? As x equals to x naught, what is y? Anish, answer though. At x equals to x naught, what is y? Everyone, after thinking, age x equals to x naught, what is y value here?
0.
Good. So, equation form हामी के गर्न सक्छौं? Y value 0 minus f of A equals to fb minus fa over b minus a, x equals to x naught minus a. What we find? X naught. After simplification, we are going to find x naught. X naught is our first approximate solution. Okay, A and B are two initial guess root, initial guess point for the root of the non-linear function f of x equals to 0, right? Okay, age x equals to x naught, we can put y equals to 0 in equation number 4. Then we can find x naught. let we see x naught equal, very simply we can find after simplification. ओके पक्का है म बोर्डमा थिएँ त्यसैले कसरी जान्छ यो व्हाइट बोर्डमा छु might be ठीक छ. Okay, when x equals to x naught, we can write y equals to 0. Everyone see the equation number 5. Very simply, after simplification, we can get x naught. X naught is the first approximate solution. Okay, we know a and b. These two are initial guess point of our roots. We have, after simplification, we have a times f b minus b times f a over f b minus f a. Okay, derivation ni hamलाई सोध्छ. Just very simply you can make a curve with chord and find the equation of the chord. After that you see take x equals to x naught. As x equals to x naught, we see the y values there, zeros. After simplification, x naught equals to a times f b minus b times f a over f b minus f a. This is the first approximation of the root. Okay, everyone, तिमीले बाइसेक्सन मेथडमा जे गरेको थियो हामी त्यही गर्छौं. If f of x naught equals to 0, x naught is the required roots. If f of x naught is not 0, what we have? We move for next approximate solution, x1. What is the formula? x1 को लागि फेरि we follow this formula, but we should careful about the new a and b. Okay, how to choose a and b? We can choose a and b. How can we choose? Bisection method मा जसरी choose गरेछौं हामी त्यसरी नै we follow the rules from bisection method. The first approximation of the roots is x naught. If f of x naught equals to 0, x naught is the roots, but not we follow for next approximation. Okay, for next detail लेखा छैन हामीले. If f a and f of x naught have opposite sign, हामी के भन्न सक्छौं? Then the root lies between a and x naught. Okay, we replace b for x naught. Then we follow this formula. A भनेको पहिलेकै पायो, b भनेको new x naught, updated one. Okay, always we follow to take x naught, updated one लाई लिन्छौं र old a र b मध्ये कुन लिने? हामी just we see the sign f a and f of x naught. If f a and f of x naught have opposite sign, a is this, x naught we replace x naught for b. A formula use गर्ने हो भने होइन भने you follow a times f of x naught minus x naught times f of a over f b भनेको f of x naught minus f of a. Okay, sir. Every mute गर. म्युट गरेको छौ. Anyway, ठीक छ. त्यही अघि नै म तिमीले हँसाउने कुनै जोक्स वा समथिङ केही भन भने थिए. Anyway, we feel very happy now. अब स्टप गर, म्युट गर. तिमी बुझिराछौ मैले भनेको कुरा? x naught हाम्रो required roots होइन भने हामी x1 निकाल्न जान्छौं. x1 को लागि न्यू a and b हामी फाइन्ड आउट गर्छौं. त्यसको लागि x naught एउटा भ्यालुज a b मध्ये एउटा हुन्छ. अब ओल्ड a र b मध्ये तिमी कुन लिने? त्यसको लागि हामी के गर्छौं? f a and f x naught लाई मल्टिप्लाई गर. अपोजिट साइन भयो भने हामी a भनेको a नै भयो ओल्ड a र x naught लाई b मान्न सक्छौं. Then root lies between a and x naught and replace b by x naught in the equation 4 and obtain next approximate root x1 from equation number 5. Otherwise, if f a and f of x naught, product of these two does not have negative sign, okay, हामी के गर्छौं? root must lies between x naught and b. यो हुन्छ नै हाम्रो. यो फेल भयो भने तिमी रूट्स फाइन्ड आउट गर्न सक्दैनौ. and replace a by x naught, b old values b नै भयो हाम्रो b भनेको. Then we follow equation number 5 for next approximate roots x1. Compute next approximate root x1 from equation number 5. Clear? So just what false position method is stand for? Function should be continuous. We need to have two initial guess point where if we suppose initial guess point A and B, F and F are opposite sign, then root exists from bisection method, and we follow the formula. This x naught or approximate roots equals to A time Fp minus B time Fa over Fp minus Fa. This x naught is not our required roots. We follow for next approximate. Then हामी कहिलेसम्म रिपिट गरिराख्छौं यो कुरा हामी यहाँ डिस्कसन गर्छौं. स्टेप 1 के छ फल्स पोजिसन मेथड को अल्गोरिदम. म फिगरमै ब्याक हुन्छु त्यसैले मैले व्हाइट बोर्ड बाटै लिइराखेको. एभ्रीवन लिसन केयरफुली. Step 1, we have to choose two initial guess A and B, where F and F are opposite sign. If F and F greater than 0, root does not contain A and between A and B. Okay, हामी फेरि initial guess pointहरु change गर्छौं such that F and F are opposite sign. After that, we compute initial guess. यो x naught हो. Here I write x1, x naught hoyo. X naught equals to this. We compute f of x naught. If f of x naught equals to 0, x naught is our required roots. This is the algorithm. If f a into f of x naught opposite sign, product of these two, root lies between a and x naught. We set b equals to x naught and we follow above formula. If not, else root lies between x naught and b. Set a equals to x naught and we follow the next approximate roots x1. Okay, x1 equals to a times fp minus b times fa over fp minus fa. We repeat our process until we get our last approximate solution minus second last approximate solution को absolute difference strictly less or equals to our pre-specified error. We call it as epsilon. Epsilon or epsilon. Okay, then xn, our last approximate solution is the required roots. Okay, यो अल्गोरिदम हो. तिमीले हाम्रो सफ्टवेयरमा म्याटल्याबमा प्रोग्रामिङ बनाउने बेलामा यो लजिक लगाउन सक्छौ. ओके, इनिशियली हामी फंक्सन डिफाइन गर्छौं र या फेरि एफपी पोजिटिभ छ नेगेटिभ छ. इफ एफए एन्ड एफपी ग्रेटर देन 0, रूट्स डज नट एक्जिस्ट, एल्स रूट क्याल्कुलेट गर्छौं हामी x1 इक्वल्स टु दिस भनेर. व्हाइल फर लुप र व्हाइल लुप और इफ हामी ब्रान्चहरु पनि अप्लाई गरेर युज गरेर सल्भ गर्छौं. आई ब्याक हियर. ओके, एभ्रीवन लिसन. सी फिगरमा हेर, सबैले हेरिराछौ. यो फिगरमा हामी हेरिराछौ x नट कसरी क्याल्कुलेट गर्यौं. अब x1 को लागि हामी सिम्पली हेर्छौं. आई ड्र दिस लाइन. यो लाइनबाट अघि यहाँबाट क्लिक गरे थियो. आई ड्र लाइक दिस. एभ्रीवन सी. तिमीले यहाँ भेट्छौ x1. दिस पोइन्ट इज x1. x1. ओके, वी सी x1. अब तिमीले फेरि कर्ड फर्मुला कसरी लगाउने? दिस वी मुभ लाइक दिस. यो फर्मुला लगाउँछौ. अघिकै 2 पोइन्ट हामीले लिइरा थियौ. एफ एन्ड एफ आर अपोजिट साइन. अहिले एफ बी भनेको एक्स नट भयो. एक्स नट एफ अफ एक्स नट पोजिटिभ. फेरि तिमीले एफ अफ ए नै लिनु पर्यो. फेरि हामी यो न्यू कर्डको फर्मुला लगाउँछौ. सी हियर ब्लू लाइन. तिमीले x1 फाइन्ड आउट गर्यौ. फर x2 वी फलो नेक्स्ट. वी ड्र लाइक दिस. ओके, तिमीले फेरि के गर्छौ? x1 के भयो? एफ अफ x1 पोजिटिभ भयो भने a र x1 लिन्छौ. फेरि नेक्स्ट कर्ड डेराइभ गर्यौ. हियर वी have x2. Okay, we repeat our approximate solution until we get our desired accuracy. Or तिम्रो roots भनेको यो रेड लाइनले कट गरेको ठाउँ हो. This is our root, everyone. See. Okay, मैले कड कसरी रिपिट गरे तिमीले देखिराछौ. x0, x1, x2. This is not x3. We have x2. Move गर्छौं हामी until we get our desired accuracy. So this is called the method of chord. हामी कड फर्मुलाबाटै यो एप्रोक्स रुट फर्मुला डेराइभ गरिरा छौं कसैलाई यो फिगरमा केही कन्फ्युजन छ भने प्लिज आस्क केही छ कसैले सोध्न सक्छौ केही छ केही छ anyone I wait this method of chord I draw the chord you see x1 okay again we have x1 भनेको के पायो x1 f of x1 ordinate हामीले पोजिटिभ पायौं यो पोइन्ट र तिमीले यहाँ देखिरहेको यो पोइन्ट र f of x1 को यो पोइन्ट र हाम्रो यो पोइन्टको बेसमा हामी फेरि न्यू फर्मुला वा न्यू एप्रोक्सिमेट सोल्युसन x2 निकाल्छौं त्यसपछि अगेन यु ड्र द कर्ड f of x1 पनि पोजिटिभ भयो ओके नेक्स्ट वी मुभ लाइक दिस छैन भने म अघि बढ्छु ओके यो अब हामी प्रब्लममा जान्छौं सो एभ्रीवन नो what is the roots formula from bisection method initially we have a and b okay x naught is the first approximate solution a times f p minus b times f a over f p minus f a okay ठीक छ तिमीले क्वेशन छ भने सोध्न सक्छौ फल्स पोजिसन मेथड हामी प्रब्लममा जान्छौं तिमीले एउटा प्रब्लम यहाँ गर्नुपर्ने हुन्छ सबैले देखेको छौ अनिस देखेको छ अनिस हेलो हेलो
मैम चैट बक्स में यस मैम लेखिरहेको छ
ए ओके त्यो मैले देख्दिन नि त्यसैले हेर्न त सकिन्छ ल ठीक छ भेरी गुड ठीक छ के देखेको छौ फल्स पोजिसन मेथड हो प्रब्लम पार्ट
Yes, sir.
ओके मैले पढिरहेको सुनेको छौ एक्जाम्पल नम्बर 1 फाइन्ड ए पोजिटिभ रुट अफ द इक्वेसन x times e to the power x equals to 1 using false position method roots lies between 0 and 1 okay many times हामीलाई correct to 4 decimal place correct to 3 decimal places दिन्छ अहिले मैले correct to 3 decimal places मा हेरिरा छु we have a and b 0 and 1 okay हामी क्वेशन मा जान्छौं f of x equals to x to the power e to the power x minus 1 we have this function equation देखिरा छौ equal to some constant we compute f0 and f of 1 what we see a and b 0 and 1 fa and fp here we see fa f of 0 minus 1 f of b f of 1 1.7183 okay f0 into f of 1 less 0 opposite sign f0 and f of 1 root lies in the interval 0 to 1 we claim our false position method exists to find the root of the function equation x e to the power x equals to 1 let we take x naught be the first approximate solution what is the formula a is here 0 b is 1 we have f of 0 and f of 1 what is the formula for x naught first approximate solution a times f of b minus b times f of a over f b minus f a here we have a equals to 0 and b equals to 1 after simplification we get easily you can simplify 0.3679 we find f of 0.3679 like f of x naught if f of x naught equals to 0 x naught is our required roots here what we see here f of x naught not equals to 0 f of x naught equals to minus 0.4685 everyone see x naught this x naught is not a roots again we need to find the roots okay what is new a and b be careful what is a and b new a and b anjali बोलो तो Anjali? सुनेछौ?
Yes, ma'am.
Okay, सुनिराख है. X naught, we have A and B. We find F A and F B. F A and F B are opposite sign. Root lies between 0 to 1. Okay, for first approximate roots or approximate solution X naught, we find 0.3679 from false position method, right? F of 0.3679 not equals to 0 means this is not roots. Okay, our next step ma janda what will be A and B? What are the possible A and B? हामी त्यही छलफल गरेको हो. तिमीलाई सोध्न गए म. कसरी पत्ता लगाउने A र B भन त? रुल साथीहरुलाई सुनाइदेऊ. अब न्यू A and B or x1 को लागि A र B के हुन सक्छ?
0.3679
Oh, very good. न्यू ओके अपडेटेड वानलाई हामी ए वा बी मध्ये एउटा लिन्छौँ र ओल्डलाई कुन हुन्छ भनेर हेर्छौँ. एफ अफ 0.3679 ले नेगेटिभ भ्यालुज दिएछ भने ओल्ड ए र बी मध्ये पोजिटिभ दिने लिन्छौँ, 1 लिन्छौँ. जस्ट फर न्यू एप्रोक्सिमेट x1 वी चुज ए. Always A strictly less B. Okay, we see here the 0.3679 लाई A suppose गर्छौँ. तिमी सुन्न गाह्रो भने अनम्युट गर. 0.3679 A, B is 1. Okay, A and B for new approximate solution. Next approximate roots x1. We follow A equals to 0.3679, B equals to 1. We have formula A times F of B minus B times F of A over F B minus F A. Again we have next approximate roots 0.5039. Is this a root? We check F of 0.5039. This equals to 0.1674. Okay, F of x1 not equals to 0. X1 can't be roots here. X1 is not our desired roots. Okay, for again we find next approximate solution x2. What is A and B for x2? Okay, latest updated one 0.5033 हामी लिन्छौँ. 5. यो लेटेस्ट अपडेटेड वान लिन्छौँ. ससिता सापकोटा सबैले थिंक गरिराख ल. ससिता?
Yes, ma'am.
ओके, 0.5033 यो हामीले लियम x2 को लागि A वा B. अब ओल्ड मध्ये कुन लिने भन त? ओल्ड वान
जुनले चाहिँ पोजिटिभ भ्यालु दिन्छ त्यो चाहिँ लिने, त्यही F1 लिने.
F1, भेरी गुड. F1 लिने. ओल्ड 3 छ हाम्रो पोइन्टहरु. त्यो मध्ये जुनले पोजिटिभ ओर्डिनेट दिन्छ त्यो लिने. अहिले के दिइराछ? नेगेटिभ ओर्डिनेट. हाउ टु चुज न्यू ए एन्ड बी, हाउ टु चुज न्यू इन्टरभल, त्यसमै हामी जान्छौँ. ओके, थ्याङ्क यू. हामी एउटा 0.5033 लिन्छौँ. ओल्ड 3 मध्ये 1 नै चुज गर्छौँ फर न्यू. For next approximate roots, root lies between 0.5033 and 1. Why? We have F of 0.5 into F of 1 is strictly less 0. These two are opposite sign. Okay, next formula हामी के गर्न सक्छौँ? x2 equals to, again we have A times F of B minus B times F of A over FB minus FA. That equals to 0.5474. If F of 0.5474 equals to 0, x2 is desired roots. Okay, but we have F of 0.5474 not equals to 0. This is x2 is not a desired roots. Okay, we continue this process. We can obtain this table. हामीले पहिला पनि गरिसकेको छौं. यो वेबाट हामी जान सक्छौं. स्मल a हामीले यो म पछि बनाउँछु. स्मल a. Okay, iteration process. Your table like here. Iteration 0 means xi, I runs from 0 to 9 or 0, 1, 2, 3 up. A, B, xi, x0, x1, x2, x3, x4, x9. F of xi, F of x0, F of x1, F of x2 up to F of x9. Just we see the sign of F of 0, F of x1, F of x2. Okay, हामीले यो अघिकै process. Initially we have 0 and 1. we find roots x0. x0 is this. Okay, f of x0 is negative sign. Okay, तिमीसँग तीनवटा point भयो 0, 1 and 0.3679. अब यो x1 को लागि हामी के लिन्छौं? Updated x0 लिन्छौं. See here 0.3679, 0.3609. Old 0 र 1 मध्ये हामी कुन लिन्छौं? यसले नेगेटिभ भ्यालु ordinar दिन्छ भने पोजिटिभ ordinar दिने 1 लिन्छौं. Okay, A and B, new A and B is 0.3679 and 1. Again, we find x1 from the formula. Okay, by false position method, we have 0.5033. We take f of x1, f of x1 not equals to 0. This is negative. Okay, तिमीले 0.5033 लिनै पर्यो. Third x2 को लागि, third approximate solution को लागि, we choose this 0.5033. Old values हामीसँग कतिवटा छ? तीनवटा छ. 1, 2, 3. तीनवटा मध्ये तिमी कुन लिन्छौ? मतलब you back 1 and 0.3679. Which one we choose? 50 ले negative ordinate दिएको छ भने positive ordinate दिने choose गर्ने. Okay, for x2 we have A equals to 0.5033. B equals to 1. We follow the formula and we can easily find x2 from false position method. Okay, similarly we proceed and we find up to x9. See here, x9. What is x9 and x8? Here we see x9 is 0.5671. Here we see x8 is 0.5671. Here we see x7 equals to 0.5671, 0.5670. तिमीले question सोध्न सक्छौ, ma'am, can we stop at x7? Okay, we can stop here. More refine हुन्छ तिम्रो answer. तिमीले बढाउँदै गयो भने, but you can stop when our criteria is fulfilled. जहाँ गएर तिम्रो criteria fulfill हुन्छ. Here we see x7 minus x6 equals to 0.0001. Okay, correct to 3 decimal places. हामी हेर्न सक्छौं. The root of the equation correct to 3 decimal places is 0.5671. यसलाई तिमी x9 or simply x मान्न सक्छौ. x0 लेखिरहेछ. Later on I correct and तिमीलाई पठाउने छु. Okay, you can stop up to x7 or you can stop up to x8. x8 minus x7 equals to 0. Strictly less or equals to our pre-specified error. Correct to 3 decimal places means timro last or second last approximate solution ko absolute difference must less or equals to 0.0005 hunu parcha. Then you accept our last approximate solution is our required roots. Okay, 0.5671. Correct to 3 decimal places सम्म लेख्ने हो भने you can write your answer up to 3 decimal places 0.567. Okay, Anjali, सबैले सुनेको छ? कसैले सुनेको छैन भने भन्न.
Yes, ma'am.
Okay, clear छ भने यो क्वेशन हामी प्र्याक्टिस गर्छौं. मैले यहाँ हिन्ट्स आन्सर मात्र लेखेको छु सबैलाई सजिलो होला भनेर. क्वेशन मा जाउँ. Find a root of the equation. Okay, x cube minus twice x minus 5 equals to 0. We have the equation of degree 3, having degree 3. Okay, this is non-linear equation. Define and close interval 2 to 3. Okay, you solve, you find the roots. Solve means we are going to find the roots. Correct to 3 decimal places by using false position method. Right, correct to 3 decimal places means everyone see here 2 up x6 minus x5 equals to 0.002. Correct to 3 decimal places. What is our pre-specified error? Our pre-specified error is 1 by 2 into 10 to the power minus 3. That equals to 0.005. See here, x6 minus x5 is strictly less or equals to 0.005. So we conclude x6 equals to 2.0945. This is our required answer. तिमीलाई कहिले काहीँ सोध्न सक्छ correct to 5 significance figure. 1, 2, 3, 4, 5. This is the digit number correct to 3, correct to 5 significance figure. हामीले यही देख्छौँ. Correct to 5 significance figure means what we see. देखिरहेछौ तिमीले? No. Listen carefully. हामीले लेखिरहेको एन्सरको फर्म मात्र मैले भन्न खोजेको. करेक्ट टु 3 भन्यो भने 1/2 into 10 to the power -3 गरेर तिमी एरर चेक गर्न सक्छौ. करेक्ट टु 3 डेसिमल प्लेसेस means आफ्टर डेसिमल प्लेसेस तिमीले के गर्न सक्छौ? अप टु 3 डिजिट एन्सर राख्न सक्छौ. तर कहिलेकाहीँ हामीलाई करेक्ट टु 5 सिग्निफिकेन्स फिगर भनेर एन्सर पनि मागिरहेको हुन सक्छ. ओके, यसरी माग्यो भने हामी सबै लेख्छौँ 1 2 3 4 5. Number of significant figure is here 5. Okay, next question ni ma discussion garchu, त्यसपछि तिमीले टास्क गर्छौ. Find a root of the equation. We have the equation 4e to the power -x sin x minus 1 equals to 0. Define on 2 to 3. Correct to 3 decimal places. Okay, by using false position method, we have given the roots lies between 0 and 0.5. Sometime we have a and b. If we have no a and b, we have to choose a and b such that FA and FB are opposite sign. Be careful everyone how to choose A and B. Okay, तिमीलाई गाह्रो इक्वेसन छ भने A and B दिएको नै हुन्छ. यसको एन्सर यहाँ पाउँछौ. You know how can we find? ठिक छ, यो दुईटा क्वेसन हामी अहिले सल्भ गर्छौं. एटलिस्ट वान सबैले गर. यसको एन्सर त छ तर गर्नु पर्यो. हुन्छ, everyone try this question number 2. फल्स पोजिसन मेथडमा केही कन्फ्युजन छ भने तिमीले सोध्न सक्छौ. छैन भने हामी न्युटन राप्सन मेथड नेक्स्ट मेथडमा जान्छौँ. त्यो भन्दा पहिला तिमीले 15 मिनेट टाइम लिन सक्छौ. 10:05 सम्म क्वेसन नम्बर 2 र 3 मा हामी जान्छौँ. ओके, केही भन्नु छ? केही क्वेसन छ? एनीबडी हैव एनी क्वेसन? ठीक छ. Okay, everyone try this up to 10:5. Find the root of this equation accurate to 3 decimal places by using false position method. ठीक छ, म अटेन्डेन्स लिन्छु है. तिमीहरू गर्दै गर. देखेको छौ? कोही बोलेन? स्नेहा?
हजुर म्याम.
देखेको छ स्लाइड? अलि सानो बनाए मैले त्यो अटेन्डेन्स लिनको लागि. देखेको छौ होला है? देखिरहेछ है. पन्ध्र मिनट टाइम लियो. यो क्वेसनको एन्सर मात्र छ यहाँ. म क्वेसन देखाउँछु, सबैले गर्दै जाऊ. आशिष क्वेसन लिऊ ल. देखेन भने भन. देखेको छैन जस्तो लागिरहेछ है. आशिषसम्म आएको छ. आशिष
म्याम
हजुर
त्यो क्वेसन नम्बर 3 मा के हाम्रो इन्टरभल 2 3 दिएको छ नि
क्वेसन नम्बर 3 मा 0 टु यस्तो इन्टरभल 2 to 3 दिए पनि तिम्रो चाहिँ रुट लाइज बिट्विन तिमीले लिन सक्छौ चुज गर्न सक्छौ या फेरि एफपी 2 र 3 नै लिन पनि सक्छौ या फेरि एफपी चाहिँ अपोजिट साइन हुन्छ भने छ होला पक्कै हुनुपर्छ ओके गिभन दैट द रुट लाइज बिट्विन 0 and 0.5 त्यो दियो भने एफ ए र बी 0 र 0.5 लिन सक्छौ जति रुट्सको नजिक तिमी लिन्छौ रुट सायद अब 0 र 0.5 को बीचमा छ भने तिमी कम इटरेसनमै एन्सरमा पुग्न सक्छौ सायद कममै पुगेको होला हेर त रुट्स कति रहेछ 0.371 रहेछ 0.371 2 र 3 लियो भने इट टेक्स 20 टाइम्स 20 इटरेट प्रोसेस गर्नु पर्यो ठीक छ टेन्टेटिभ रुटको नजिकतिर नै लिन्छौँ हाम्रो क्वेसनको एन्सर वेटेज नम्बरको वेटेजको आधारमा एटलिस्ट डिफाइन गर्छौँ दिएको हुन्छ वा तिमीले चुज गर्नु पर्यो गुड क्वेसन इभन रुट लाइज बिट्विन 2 to 3 इट्स ओके बट वी चुज ए एन्ड बी 0 and 0.5 रुट्स 0.371 छ रुट्सको नजिकको या फेरि एफपी अपोजिट हुने साइन तिमीले लियो द्याट्स गुड ओके फर्स्टको सबैले गर्दै होला Hello, Anis. Hello. Hello. Okay, सुरु गरौँ ल Newton-Raphson method. This method is based on Taylor series expansion. Initially, we have one approximate roots of the
म्याम हजुरको
equation.
स्वर एकदमै सानो आइरहेछ
हो र तिमीले ठुलो गर्दा नि त्यस्तो भयो कि पक्कै Newton-Raphson method सुनेको हो अहिले ठुलो सुन्यौ
सुन्यो म्याम
Okay, this method is based on Taylor series expansion. Here we have only one initial case. Let x not be an approximate root of the function f of x equals to 0. This is the initial case. In bisection and false position method, we need two initial case, but here we have only one initial case of the equation f of x equals to 0. Let's say x1 equals to x naught plus h, some increment from initial case or initial root. X1 equals to x naught plus h be the correct solution, so that if x1 is the correct solution, त्यसलाई function मा लगेर राख्दा what we have equation मा राख्दा f of x1 equals to 0. Okay, in Newton-Raphson method we need only one initial case. Okay, let's say x naught be an initial guess point of the function or equation f of x equals to 0. Okay, x1 लाई हामीले correct solution मान्यौ, correct roots. If x1 is the correct roots, f of x1 equals to 0. But what is x1? Some increment from x0, some changes from x0 point, x0 guess point. We suppose x0 plus h be the correct solution, that is x1, right? See here, f of x0 plus h equals to 0. Can you write f of x0 plus h equals to 0? F of x equals to 0 is our equation. X0 plus h is x0 plus h is our correct roots. So f of x0 plus h equals to 0. We use Taylor series expansion for a function of single variable. What is our variable? X0 plus h, like x0, some increment from x0. Okay, f of x0 plus h. How to expand? Everyone know we can easily expand the Taylor series for a function of single variable. F of x0 plus h. F of x0 plus h times f dash x0 plus h square over 2 factorial f second derivative at a point x0 plus h cube over 3 factorial f triple derivative at point x0 plus dot dot dot. Okay, we can neglect second and higher derivative term under the assumption that h is sufficiently small. हामीले फर्स्ट च्याप्टरमा पनि भनिसक्यौ. We neglect second and higher, h square second derivative, this form and higher. Okay, what we have, just we have f of x0 plus h times f dash x0 equals to 0. See here, we neglect second and higher derivative term. Okay, just we have f of x0 plus h times f dash x0 equals to 0. Your term कसरी आयो? Everyone know. If we have any confusion, you can ask. F of x0 plus h times f dash x0 equals to 0. This is the Taylor series expansion. Okay, हामी यहाँ पुग्यौं. What is our solution? X1 is our correct solution. Okay, what is x1? X1 equals to x0 plus h. Initially we know x0, just we need to find h. What is h? See here, f of x0 plus h times f dash x0 equals to 0. This we have. यो हामीले equation 6 बाट break गर्यौ तिमीले. Which gives what is h? H equals to minus f of x0 over f dash x0. Everyone know how can we find h? h equals to minus f of x naught over f dash x naught, first derivative of given function at a point x naught, initial guess. Thus, the first better approximation is given by x1 initial guess. I mean, next approximate roots ke payo, x1 equals to x naught plus h. See here, x1 equals to x naught plus h. x1 equals to x naught minus f of x naught over f dash x naught. Okay, we can find x1. Next, how can we find x2? If we know x1, how can we find x2? x2 equals to x1 minus f of x1 over f dash x1. Okay, similarly, we have formula xi plus 1 equals to xi minus f of xi over f dash xi. What is I? I runs from 0, 1, 2, 3 up. We repeat our approximate solution until we get the desired accuracy. Initial approximate solution like x naught na mane no bhane, x1 mane bhane, you can run I from 1, 2, 3 up. If I equals to 0, see here, x1 equals to x naught minus f of x naught over f dash x naught. Initial, we need x naught initial guess maneko so when I runs from 0, 1, 2, 3 up. If we suppose initial guess point x1, I runs from 1, 2, 3, 4, 5 up. Age I equals to 1, what we have? x2. x2 equals to x1 minus f of x1 over f dash x1. Initial approximate roots or initial guess point to find the root of given nonlinear equation. हामी x naught or x1 के मान्ने, हामीले x naught मान्दै हाल्छौँ, त्यही नै मान्छौँ. Okay, as we suppose initial guess x naught, here I runs from 0, 1, 2, 3 up. This is the Newton-Raphson formula to find the root of the equation f of x equals to 0 with only one guess x naught. Here I runs from 0, 1, 2, 3 up. Everyone know how can we find? Initially we have the equation f of x equals to 0, non-linear equation. We need to find this root from Newton-Raphson method. Okay, let we discuss what is the formula. X naught we know the initial guess. We suppose x1 correct roots. X1 is nothing, it is x naught plus some increment from h, x naught plus h, some increment from x naught, we say x naught plus h. F of x naught plus h equals to 0. This is the x naught plus h is the roots. F of x naught plus h must equals to 0. We expand this f of x naught plus h by Taylor series, right? Taylor series expansion for a single variable. We neglect second and higher derivative term as we assume h is sufficiently small. Okay, we have f of x naught plus h times f dash x naught equals to 0. We know x1 is the correct roots. Let us say x1 is the correct roots. x1 equals to x naught plus h. Just we know x naught. We need to find h. Here h equals to this term. h equals to minus f of x naught over f dash x naught. Okay, just we replace x1 equals to x naught plus h term. Similarly, we find the successive approximation or general formula for Newton-Raphson method to find the root of the function xi plus 1 equals to xi minus f of xi over f dash xi. This is the Newton-Raphson formula to find the root of the function f of x equals to 0. But we need only one guess point. Let's say x naught. हामी अघि बढ्छौँ. Geometrical meaning. What is the geometrical meaning? हामी draw गर्न सक्छौँ अघिको जस्तै गरेर. Geometrically, the Newton-Raphson method approximate the curve of f of x. Curve of f of x by tangent. See here, tangent line. Initially, we suppose x naught. See here, point P to x-axis. X naught is the initial guess. How can we find next approximate? Next approximate x naught is here. We draw the tangent line, this line. another point x1 हामी यहाँ लिन्छौं draw गर्न सक्छौं x1 again we draw the tangent line x2 again we draw the tangent line x3 हामी पुग्छौं our desired root xi सम्म geometrically the Newton-Raphson method approximates the curve of f of x by tangent. The first approximation to the root of the equation f of x equals to 0 is what? Is the point of intersection of the tangent drawn at the point to the curve of f of x with the x-axis as shown in figure below. Okay, the root of the equation y equals to f of x is nothing. It is the point of intersection of the tangent where we draw it drawn at the point to the curve of f of x with the x-axis. This is the initial guess. X naught. This is our first approximate solution. This first approximate solution we called it as x1. This is the point of intersection of the tangent drawn at the point to the curve of f of x with x-axis as shown in figure below. Right? तिमीले देखिरहेछौ figure मा. Next, we have Newton-Raphson's algorithm. First, we need to choose initial guess. Let's say x naught. Compute f of x naught and f dash x naught. हामी programming मा त्यही गर्छौं. Then we find x1 with the approximate formula, Newton's formula for the root of the function x1, x naught minus f of x naught over f dash x naught. Okay, we repeat our approximate solution until we get the desired accuracy. Our desired accuracy is nothing. It is absolute difference of last and second last approximate solution is strictly less or equals to epsilon. हामी check गर्छौं. Check the accuracy for the latest estimate if x1 minus x naught is strictly less or equals to epsilon. We stop. x1 is our desired roots. होइन भने else we repeat our process from step 2, 3, 4 सबै तिमी repeat गर्छौ until we get the desired accuracy. Okay, हाम्रो problem मा जान्छौं हामी. We have Newton-Raphson formula. Okay, see here, find a problem, find a real root of the equation. We have equation as cube minus thrice x plus 2 equals to 0. We find the roots of this equation by using Newton-Raphson method. Initially, what we have a function f of x equals to x square minus thrice x plus 2. Find its derivative. Just we have 2x minus 3. We have the Newton-Raphson formula. Xi plus 1 equals to xi minus f of xi over first derivative of function f we called f dash xi, where I runs from 0, 1, 2, 3 up. Let's say x naught equals to 0 be the first approximate solution. तिमीले यहाँ question गर्न सक्छौ. Okay, how can we choose initial guess? Sometime we need to choose, we need to guess. How can we guess? Just we need to see tentative roots तिमीले find out गर्ने. हामी कस्तो problem को लिन्छौं? Problem which have no analytic solution or the solution is more tedious. अहिले यो problem लिए पनि तिमी त्यस्तो problem हरुको roots निकाल्दै छौ. यसको solution probably 1 हुन्छ. अब त्यसो भए can you choose initial guess 0 or 0.5 or 0.75 or 0.80? Okay, we can choose. Listen carefully, how can we choose the initial guess? First, sometime we have, no need to worry. If we have no initial guess, how can we choose? Just we see tentative roots of this function. Calculator वा अरु help ले तिमी निकाल्छौ. जुन गाह्रो छ तिमीलाई राख्दिएको हुन्छ. त्यसपछि तिमीले अहिले यसको solution 1 हुन्छ. Let's see, 1 square minus thrice into 1 plus 2. We have to cancel out. X equals to 1 is it's a real or analytic or exact solution. Okay, how can we move? यसको solution, though we have analytic solution, we can follow the approximate roots also. हामीले पहिला पनि discussion गरेको छौं. Can we choose X naught equals to initial guess equals to 0.5. Yes. The answer is yes. 0.75 S, 0 S or 0.30 S. तिमी जति नजिक लिन्छौ त्यति इटिरेसन कम हुन्छ, राइट? कसरी अघि बढिरहेछ हामीले फिगरबाट पनि देखिसक्यौं को छौं. ओके, हाउ टु मेजर, हाउ टु मुभ फ्रम अप्रोक्सिमेट इनिशियल गेस टु रियल रुट्स or correct roots or desired roots. हामी त्यो फिगरबाट हेरिसकेको छौं. Let we suppose, let's say x naught equals to 0, then the first approximate is computed by this formula. X1 equals to, we have this formula, just put I equals to 0, 1, 2, 3 up. We repeat our process until we get the desired accuracy. Here x1 equals to x naught 61. So x1 equals to x naught minus f of x naught over f dash x naught. Just you find x1 equals to 0.6667, right? X2, we have x1. X2 equals to x1 minus f of x1, f dash over f dash x1. We find 0.9333. Okay. Similarly, x3 this, x4 this, x5 this. You can stop here, or we know the roots converge 1. तिमीले exactly 1 भेट्यौ भने we feel happy, since see यो 1 लाई लगेर function मा राख, f of 1 equals to 0. This is the correct roots. See everyone. Okay, next question number 5. हामी just discussion मात्र गर्छौं. Find the root of the equation x times sin x plus cos x equals to 0. Okay, we have function this, its derivative x cos x. The iterative formula is अघि लेखे जस्तै xi plus 1 equals to xi minus f of xi over f dash xi. मैले n लेखेछु. n equals to what? n equals to 0, 1, 2, 3, 4 up. We repeat our n until we get the desired accuracy. N equals to 0, 1, 2, 3. Let's say x naught equals to pi. Okay. The successive iterative are given below. मैले direct गर्दै. N equals to number of iteration 0, 1, 2, 3 up. Xn means our roots. No. Xn plus 1 is our root. See the formula. Xn plus 1 is our roots. Okay. Xn, x0, x1, x2, x3. If we know x0, we find x1. As n equals to 0, we have x1 equals to x0, n equals to 0 minus f of x0 over f dash x0. We see x1 is this. Similarly, if we know x1, n equals to 1, we find xn plus 1, x2. x2 equals to n equals to 1. Highlight x2 minus f of x2 over f dash x2. Okay, we find 2.7986. Similarly, n equals to 2, what we have is n equals to 2. x3 equals to n equals to 2. x2 minus f of x2 over f dash x2, 2.7984. As n equals to 3, we find x4. x4 equals to x3 minus f of x3 over f dash x3. See here, we have f of x4 equals to 2.7984. See x4 and x3. These two are equal. As we see absolute difference of x4 minus x3, we have 0, 0.000, right? It means our required solution correct to 3 decimal places. What we have? 1 by 2 pre-specified error, 1 by 2 into 10 to the power minus 3, 0.0005. The absolute difference between 2.7984 minus 2.7984 equals to 0, strictly less or equals to 0.0005. Our criteria is fulfilled. We say x4 equals to 2.7984 is our required solution. 2.7984 is our required solution. Similarly, here we have the problem Using Newton-Raphson method, we have to find a real root correct to 3 decimal places of the equation sin x equals to x by 2, given the root lies between pi by 2 and pi. Okay, pi by 2 and pi. Root lies between pi by 2 and pi. Can we choose? Initial guess x naught equals to pi by 2 or pi or between pi by 2 and pi. Okay, we can choose. तिमीले लिन सक्छौ. How can we choose the initial guess? Just very simply, here we take initial guess x naught equals to pi by 2. Our required solution is 1.8955. हामीले तीनवटा क्वेसन यहाँ लिइराछौँ. एउटा तिम्रो आउट अफ बुक, यो सेकेन्ड एक्जाम्पल बुकको डन वर्कआउट, मेनी टाइम क्वेसन एक्जाममा सोधेको छ, फाइनल एक्जाममा. थर्ड क्वेसन तिमी अहिले गर, यो बुकको डन वर्कआउट हो. एभ्रीवन ह्याभ बुक, सबैसँग अब अनलाइन बुक छ, बुकमा पनि हेर्न सक्छौ. सबै टपिकसँग रिलेटेड सबै डन वर्कआउट बुकबाट तिमीले गर्नै पर्छ प्र्याक्टिसको लागि. एटलिस्ट डन वर्कआउट. एक्सर्साइज सेट म एक्सर्साइज सेटबाट होमवर्क पठाउँछु. ओके, आज हामी यति नै गर्छौँ. हाम्रो 1 hour 30 minute पास भयो. तिमीले लास्ट एक्जाम्पल नम्बर 6 अहिले गरेर बस. स्टेप एन्सर सक्सेसिभ एप्रोक्सिमेट एन्सर चाहिँ तिमीहरूबाटै रेन्डमली सोध्छु. एभ्री वान ह्याभ टु डु. रेडियनमा लाने तिमीलाई थाहा छ, माथि नै हामीले लेखिसक्यौँ. पाई इनिसियल गेस इज पाई. ओके, हामीले लेखिसकेको छौँ 3.1416. करेक्ट टु 4 डेसिमल प्लेस हामीले यो लेखिहाल्छौँ जहिले पनि. आफ्टर डेसिमल वी निड टु राइट अप टु 4. तिमीलाई भनेको छैन भने अब करेक्ट टु 4 भन्यो भने हामी 5 डेसिमल प्लेसेससम्म लेखेर हामी के गर्न सक्छौँ, कम्पेरिजन गर्न सक्छौँ. 1416 अर्को नम्बर पनि तिमीले लेख्नुपर्ने हुन्छ. बट हामीलाई केही दिएन भने वी फलो करेक्ट टु 3 डेसिमल प्लेसेस भनेको 0.0005 सम्म. आफ्टर डेसिमल 4 डिजिट कम्पेयर गर्छौँ. सो वी राइट 4. 4 दिएको छ भने आफ्टर डेसिमल यु सुड राइट 5 डिजिट्स. Then you can compare 1 by 2 into 10 to the power minus 4 equals to 0.000405. So up to 5 digit after decimal हामी लेख्छौँ. Okay, everyone, do question number 6. If you have any confusion, you can ask. Okay, ठीक छ, begin. Hello. Everyone do question number 6.